All right, now we're going to look at the product rule. So right here, if you have a common base, in this example, it's x, and then our powers are m and n, you're actually going to add the powers, okay? And then also just a quick note, multiplication is commutative, so if we do want to kind of switch the order that we're applying the multiplication, you can. And then one last note, if you have a term that does not have a power listed, it's understood as a power of 1 right there. So looking at example A, what's going on here, let's kind of review what we did in the previous one where whatever the exponent is, that's how many times you're going to multiply that base. So this is really saying x times x times x. And so that's the expanded form of that exponent. And then right here, x squared, that's the same thing as just saying x times x expanded. So right now it's expanded and they all have understood powers of 1. And so if we want to condense this, we go ahead and see how many x's we have. 1, 2, 3, 4, 5. So that's x to the power of 5. Now, is that how I expect you to do each problem? No. I'd actually want you to follow this product rule right up here where you just add the exponents. So this is just x to the power of 3 plus 2, which is x to the power of 5. Now, I kind of went through that demonstration just so you can get a little better understanding of why we add the powers. So looking at B right here, we have x to the power of 4 times x. Common mistake is students will just think it's x to the power of 4. They forget that there's an understood power of 1 right here. So we actually do want to add the 4 and that understood 1. And so then we get x to the power of 5. Okay, on part C, we got a lot more going on here. We have 4x squared times 3x to the power of 4. Well, what I want you to understand is that the 4x squared is really 4 times x squared. They're not actually attached. They're being multiplied together. Same thing with the 3x to the power of 4. It's really 3 times x to the power of 4. And then earlier, I mentioned the commutative property. You don't have to do this, but sometimes it can make you feel more comfortable if you kind of move things around. And so what we can do is put the 4 and the 3 together. So we'll have 4 times 3, and then we'll take the x squared and the x to the power of 4 and put those together right here, and then go ahead and clean this up because I can go ahead and multiply 3 times 4. Well, 3 times 4 is 12. Okay, so there, that's just normal multiplication. So 3 times 4 is 12. Then with the common bases right here, when you multiply, we add the power. So it's going to be 2 plus 4 for my exponent. So we're going to get 12x to the power of 6. Now, I showed a lot of detail here. Once you get pretty comfortable with the process, it's okay to go from here directly to your answer. Once you feel comfortable, you can just see that, oh, 4 times 3 is 12. I have the x squared, I have the x to the power of 4. That's a total of x to the power of 6. But here I just wanted to make sure I showed every little step. All right, we're going to look at the power rule next.